what they are saying basically, they are saying, you know, there is a refracting surface. There is a refracting surface like this, right? So there is a point P, and this point P has a normal like this, right? This is normal. You just see here. If you want, I can do that. This is what we have. Now, in first case, this is, this is angle of incidence, right? This is angle of incidence, and this is angle of refraction, right? This is this is rarer medium, rarer medium, and this is denser medium, right? So this angle is angle of refraction. So refractive index of air with reference to material is equal to sine I upon sine R. Fine. This is okay. Now, in second condition, what happens if we take, if we take normal like this? If I make this bit so a little bit smaller, because way longer is not much required. So if you draw, this is the normal, right? This is the normal, and this is the incident. This is incident ray. This is incident ray. Incident ray, right? This is angle of incidence, and angle and this is incident ray, and refracted ray coincide with the refracting surface, right? Or it makes angle of refraction is equal to 90 degree, right? Then this angle I turns to be equal to, said to be critical angle, right? Critical angle. Critical angle means when angle of incidence, for that value of incident angle for which angle of refraction is 90 degree, then it is critical angle. It is called critical angle, right? And then refractive index of air with reference to material is equal to sine I, that is angle of sine IC, critical angle, and this is sine R becomes 90 degree. Sine 90 is 1. So refractive index of air with reference to medium is equal to sine IC. By law of reversibility, when mu, the refractive index of medium A with reference to air, refractive index of material with reference to air, then it becomes 1 upon sine IC, right? So we can write it cosec IC, right? And the third one is if I take, if we take, this is the normal. Normal is, my normal is, you know, empty. It's really, normal is like this. This is what we have, refracting surface. Refracting surface, right? Surface. So when this is a refracting surface, then this is, you know, angle of incidence is like this. You. This is, this is angle of incidence, right? When this is angle of incidence, when this is angle of incidence, this is called angle I, where angle I is, angle I is greater than angle I, critical angle. When it is greater than critical angle, when angle I is greater than critical angle, then total reflection occurs. Total reflection occurs, right? So this is you can write when angle I is greater than critical angle, then total reflection reflection occurs. This phenomena only occurs. This phenomena only occurs. This phenomena. This phenomena only occurs when light ray light ray travels from denser to rarer medium. Denser to rarer rarer medium. Getting? This is the, this is the representation of that diagram which you sent. This is in one diagram. I told you in separate diagrams for better understanding. But if you do want it like this, okay, you must be happy with that. I do not have any problem. Right? Abhi, it is clear? It is clear to you. So what next is now? What you want? हाँ 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 नहीं नहीं तो you send me the numericals please वो that numericals you send me the numericals if you want to do. Should I rub this? Okay. I did that separately for your better understanding. But if you want a complex figure, I do not have any problem. I can make it more complex. I have written so many things in this, which is not written in your book. I know that, man. You came in class 10 just this year. I'm there from last 15 years. Anyway, so yeah. Send me. Start sending. Sir, हाँ, हाँ. You send me each section numericals. Each section is having approximately four. So I'll do from every section two numericals and two you will do by your own. From every section you send two. मतलब send me all. I do not remember. I remember shared they all are having same, but if you send me, let me check. I'll reduce the number. Okay. Done. Yes, I got. I got it. So there are two. One more. I hope you said me. All. No. Take anyway. There is no numerical as such. So okay. I'm starting with part one, numerical number four. Part one, part one, numerical numerical four. Right? What is given there? A ray of light of wavelength. So wavelength of light ray, wavelength and lambda 1 is equal to 5,400 angstrom, right? Yes. And suffers refraction from air to glass, refraction, refraction, air to glass. So it means air to glass is equal to 3 by 2, right? So find the wavelength of the light in glass. Okay, so refractive index. So we can, by law of reversibility, by lambda 2, we have to find. Lambda 2 means wavelength in glass. Wavelength in glass, right? This you have to find. Fine. So by law of reversibility, reversibility, refractive index of glass with reference to air, refractive index of glass with reference to air is will be 2 by 3, right? And as you know frequency frequency in both the mediums remain same, right? And frequency is same, so that is that we have v upon v1 upon lambda 1 is equal to v2 upon lambda 2. Fine. So you have to find lambda 2. So lambda 2 is equal to lambda 1 upon lambda 1 v2 upon v1. Fine. V1. So both side dividing by v2 both side dividing by V2, so this V2 and V2 is gone off, so lambda 2 is equal to lambda 1 upon uh, V1 upon V2, that is equal to lambda 1 upon refractive index of glass with reference to air, right? So now lambda 2 lambda 2 is equal to lambda 1 is 5400 angstrom, right, upon refractive index of glass with reference to air is 2 by 3. 2 by 3, so it get reciprocal and it becomes 5400 angstrom upon uh, into 3 divided by 2. This is this is 2 twos are 4, 14, 2700. So when you multiply this, so it is coming something wrong. Air to glass. Reflection is from air to glass. Sorry, I have chosen this is wrong. Right? There is wrong. It is suffering refraction from air to glass. Refraction from air to glass. Refraction from air to glass means this is the refracting surface, this is air, and this is glass, right? So this is the incident ray, and this is the refracted ray. This is angle I, this is angle R, right? So there is refractive index of glass with reference to air is equal to 3 by 2. 3 by 2, right? So what you do, you write here 3 by 2, right? You write here 3 by 2, just misinterpretation, right? So this is refractive index of glass with reference to air 3 by 2. So now when you multiply, when you divide this, then you get this is 3 and this is 2. This is 2. No, no. Just. 3 1 ja 3 1 ja 3. 3 1 ja 3. 3 8 ja 24 0 0. And 18 to, and this is 1800. 1800 into 2 is equal to 3600 angstrom. Right. This is you have lambda 2. So just I made wrong interpretation here. When it is refraction is from air to glass, then refractive index of glass with reference to air is 3 by 2. Fine. Okay. So this was question number 4. Right. Should I run this? Okay. Question number 3 is that part 1. Question number 3. Question number 3 is like that. Numerically, question is the refractive index of water with respect to air is 4 by 3. Means refractive index of water with reference to air is equal to 4 by 3. Fine. Right? What is the refractive index of air with reference to water? What is the refractive index of air with reference to water? So by law of reversibility, law of reversibility, right? Refractive index of air with reference to water is equal to 1 upon refractive index of water with reference to air. So it becomes 1 upon 4 by 3. So it becomes 3 by 4, right? When you divide it, 0.75. So refractive index of air with reference to water is 0.75. Get it? This is the answer. I hope you done this. Should I rub? Going to rub. Now come to second part. Remaining two you do it in homework. The second part you have. Second part. Second part there are two numericals only. Right? Second part there is two, no? Hmm. Okay. So this is part two, numerical two. Numerical two. What is that? What should be the angle of incidence? What should be the angle of incidence for a ray of light which suffers minimum deviation is of 36 degree, right? Through equilateral prism, through through equilateral prism, right? So in equilateral prism all interior angles of 60 degree, right? Therefore angle of prism is equal to 60 degree, right? And as I told you formula that angle of minimum deviation is 2 angle I minus angle A. Bring this I on this side, so angle of minimum deviation plus angle of prism is equal to 2 angle I. So this is 36 degree plus 60 degree is equal to 2 angle I. So it becomes 96 degree divided by 2 is equal to angle I. So it becomes 2 fours are 8 or 2 eights are 16. 48 degree. Angle of incidence is of 48 degree. Right? Done. Okay. Now the second question in this section is Second question is question number 2. Numerical number 2, we can say the ray of light, the ray of light incident of an angle of incidence 48 degree. Angle of angle I is of 48 degree, right? On a prism of on a prism of refracting angle 60 degree. Angle of refraction is equal to 60 degree. Very nice. Now suffers minimum deviation. Suffers minimum deviation, right? Calculate the angle of minimum deviation. A ray of light 60 and 48 degree on a prism of refracting angle. This is refracting angle of prism. Refracting angle of prism is equal to 60 degree, and that is equal to angle of prism. Angle of prism, right? So now we can write angle of minimum deviation. Angle of minimum deviation is 2 angle I minus angle A. So we get how much? That is 2 into 48 minus 60. Right, so it becomes 96 minus 60, it becomes 36 degree. So angle of minimum deviation is done. Done. You have done this. Now come to the third part, which you send me. That is, yeah. There is third question, part three, numerical three, numerical three. Fine. What is that? A postage stamp kept below a rectangular glass slab of refractive index 1.5. Glass slab. Refractive index of glass with reference to air is 1.5. Then, when viewed from vertically above, it appears to be raised 7 millimeter. So shift is 0. Sorry, 7 millimeter. Right. So we bring it in centimeters. So 7 upon divided by 10 centimeter. So it becomes 0.7 centimeter. Shift. So calculate the thickness of the glass slab. Thickness of the glass slab. Right. Okay. Thickness. Thickness. Thickness of glass slab. right? So real images, we have studied shift is equal to shift is equal to real depth bracket 1 minus 1 upon refractive index of uh, glass with reference to air, right? So this is 0.7, and that is real depth, real depth upon 1 minus, that is 1.5, nah? 1 upon 1.5. So decimal we have taken 5 twos are 5 threes are, so that is 0.7 is equal to real depth. Real depth is you know 3 minus 2 upon 3, right? So it becomes 1. So ये हो गया 0.7 into 3 is equal to real depth, and that is equal to 2.1 centimeter, right? So 2.1 centimeters. So real depth is equal to thickness of the glass slab. Thickness of glass slab, right? Glass slab. I hope you understand. This was question number 3. Should I rub this? Numerical 3. It was not question number 3. Okay. You're doing. Okay. Do it. Okay. So the last question of the day, numerical 2. Right? Numerical 2. What is that? A coin is placed at the bottom of the beaker containing water. Refractive index of water with reference to air is given you 4 by 3. 4 by 3, right? At a depth of 12 centimeter, right? So real depth is equal to 12 centimeter. So you have to find what height coin raise, what height, what height image of coin raised, right? Is equal to shift, that you have to find, right? So now as I told you, shift is equal to real depth bracket 1 minus 1 upon refractive index of water with reference to air, right? So shift So shift is equal to real depth is 12 bracket 1 minus this 4 by 3 turns to 3 by 4, right? This 4 by 3, when we write in denominator, then it turns to be, we will write it 4 by 3, right? It gets reciprocal and it becomes 3 by 4. And when you take LCM, 12, when you take LCM, that is 4, it is 4 minus 3, right? So you get 12 into 1 upon 4, 4 1 ja 4, 4 3 ja 12. It becomes 3 centimeter, right? To shift of image is 3 centimeter, right? Therefore, apparent depth apparent depth is equal to apparent depth of coin is equal to 12 minus 3 becomes 9 centimeter. Getting? So this much you have, right? This much we have for today.